Find the slope of the curve y equals x squared minus 3 at the point 2, 1, and the equation of the tangent line at P. Here's a quick sketch of this function y equals x squared minus 3. It looks like the standard parabola moved 3 units down. And I've drawn the point 2, 1 and a red line to represent the tangent line at the point 2, 1. We define the slope of the curve at this point to be equal to the slope of this tangent line. Here's a better picture of the function that we're talking about, y equals x squared minus 3, and the point 2, 1. In order to find the slope of the curve at 2, 1, we're going to consider a point that's very near 2, 1, and look at the secant line passing through these 2 points. Looks something like this. When the given point that I chose is very close to 2, 1, then the slope of this secant line will be very close to the slope of the tangent line that we want. Now let's define the coordinates of this nearby point. I'm going to let the x-coordinate for this point be 2 plus a small positive number, let's call it h. Then if I plug in this x-coordinate 2 plus h into the function, the y-coordinate will equal 2 plus h, the quantity squared, minus 3. So those are the coordinates of this nearby point. Let's use the slope formula to find the slope of the secant line. Using our y2 minus y1 over x2 minus x1 slope formula, we see that the slope of the secant line is the quantity 2 plus h squared minus 3, which is y2, minus y1, which is 1, divided by 2 plus h minus 2, which is x2 minus x1. If I expand 2 plus h, the quantity squared, I'll get 4 plus 4h plus h squared, using the FOIL method to multiply 2 plus h times 2 plus h. And minus 3 minus 1 will give me a total of minus 4 in the numerator. In the denominator, the 2 and the minus 2 cancel, and I'm just left with the denominator of h. Let's simplify this a little further. In the numerator, we see that the plus 4 and the minus 4 will cancel. Now I'm left with 4h plus h squared all over h. But I notice a common factor of h in the numerator and denominator. Now I can factor the numerator as h times 4 plus h. The denominator is still h. And now I can cancel a common factor of h. And we see that the simplified slope of this secant line is 4 plus h, where h represented a very small positive value. So we see that for a small positive number h, the slope of the secant line will equal 4 plus h. So what if h gets arbitrarily small? Then we can define the slope of the tangent line to be equal to the limiting value of 4 plus h as h gets very, very small. So the slope of the secant line gets closer and closer to 4 as h gets closer and closer to 0. So we will define the slope of the curve y equals x squared minus 3 at the point 2, 1 to be equal to 4. Now that we've found that the tangent line has a slope of 4, we can write the equation of the tangent line passing through this point 2, 1 with slope 4. So we can use the point slope formula for an equation of a line, y minus y1 equals m times x minus x1. The point 2, 1 gives us our coordinates for x1 and y1, so it's y minus 1 equals m times x minus 2, and then the slope is 4. This would be one equation of the tangent line passing through 2, 1 with slope 4. If we solve for y and wrote this in slope-intercept form, it would equal y equals 4x. 4 times negative 2 is negative 8. When I add 1, I would get negative 7.